Hi, I'm Dan Klimke. I'm the OptiView product manager for Fluke Networks from Everett, Washington. Nice to be here.
And I'm Zach Belcher. I'm product manager for TruView, also part of Fluke Networks, and I'm located in Austin, Texas.
I'm Stephen Ochagrosa, senior network engineer in retail. You can find me on Twitter at Stephen086, and I'm blogging at CCIE or null.net.
I'm David Varnum. My Twitter handle is at David Varnum. My blog is mindsafe.wordpress.com. I'm also in retail.
Hi, I'm Brandon Carroll. I blog at globalconfig.net, and you can find me on Twitter at Brandon Carroll.
Caleb Blankenship. I work for a bar in Alaska, and I'm on Twitter at vcabbage. I blog vcabbage.com.
I'm Rob Coote, system analyst with a public K-12 school division and Open Canadian. I blog at networkcanuck.com, and my Twitter handle is at Rob_Coote.
I'm Jody Lemoyne. I'm a network architect with Tishko Networks, also Canadian. My Twitter handle is Ghost in the Net, and I limpet blog on other blog sites that because I don't have my own, on Cisco.com and soon to be a few on Packet Pushers.
I'm Jonathan Davis. You can find me on Twitter at Subnetwork. You can also find me at subnetwork.me. I'm a senior network engineer for a large enterprise customer.
Hi, I'm Amy Arnold. I'm a network engineer in the public sector. I'm Amy Engineer on Twitter, and I blog at amyengineer.com.
I'm Bob McCouch, CCIE and independent consultant. You can find me on Twitter at Bob McCouch, and I also blog at herdingpackets.net.
I'm Pete Welcher. I've been a CCIE for way too long. I do route switch and data center consulting for Chesapeake Net Craftsman. My Twitter handle is at PJ Welcher, and my blog at netcraftsman.net.
I'm Robert Novak. I'm a deep generalist system administrator. I blog at rsts11.com, and I'm on Twitter at Gallifreyan.
I'm Tony Mackey, network engineer in the enterprise ISP and data center markets. You can find my blog at routerjockey.com or on Twitter at TONHE.
I was waiting for a .com for some reason. My name is Scott McDermott. I'm a network engineer in the public sector. I blog at mostly.networks.com, and you can find me on Twitter as at ScottM32768.
My name is Taryn Bryson. I used to be a real engineer, but now I work for a partner and spend my time telling people how great I used to be. You can find me online at SomeClown, and I blog at blog.packetq.com.
Ethan Banks. I'm a senior network architect for CareNexion, which is a telemed company, and I'm also the co-host of the Packet Pushers podcast. I blog at ethancbanks.com, and you can follow me on Twitter at ecbanks.
All right, great. Welcome. Thank you, everyone, for having us here today. Zach and I are product managers at Fluke Networks, and we're going to be speaking with you today about application-aware network performance monitoring or management, otherwise known as AANPM by many people. Specifically, we're going to talk about Fluke Networks solution using Visual TruView and OptiView XG, and we'll go through exactly what all of that means. First, of course, got to do the little tip of the hat to the corporate message. Fluke Networks is a part of the Danaher group of companies, 50,000 associates, 19 billion in sales annually. They have 5 different what they call platforms or groups of companies, and of course we're in the test and measurement platform, which consists of Fluke Networks, Arbor, and VSS, which are also here at the show, Tektronix Communications, and Fluke Industrial and Precision Measurement test equipment. And then Fluke Networks is our operating company. We growing rate about 7.5% a year, serve market size about 2 billion, and a little over 350 million in sales annually. So that's kind of who we are and where we fit in our parent company and organization. From a product standpoint, one of our core philosophies about product development from the start of when Fluke Networks was developed and initiated was the right tool for the right person or the right tool for the job. And so yes, we've got a lot of different things in different form factors, from small handheld tools, tablet tools, and server-based tools for monitoring, troubleshooting across the network, and also some tools specifically for particular uses, like our Air Magnet Enterprise product for wireless network intrusion detection and performance management, and the Network Time Machine, which is a stream-to-disk appliance. Right now, we're focusing that product on the carrier LTE market, and then Visual TruView has the ability to do stream-to-disk for the enterprise market. So just a little bit of an overview of what our focus is in our company. And of course, have to have the obligatory sheet of logos. This is basically saying that Fluke Networks, we've been around in the industry since 1993, when we first came out with our first handheld network tester. But we've grown to cover a range of verticals, and if you notice some of the names and logos, it's worldwide. Fluke Networks has presence around the world, over 250, 300 people involved actively selling and supporting our products around the world. And fortunately, we were named a leader in the Gartner NPM-D Magic Quadrant recently, and I think that's a great reflection of the commitment that we've made to the industry, some of the advances that we've made in the product line, and we're happy to have that recognition for Fluke Networks. And I'm going to, before I turn it over to Zach, just point out another thing that we've heard from the analyst community. Jim Frey from EMA, he's talking about this solution bringing together two best-in-class solutions, and that's the OptiView and the TruView together. We're going to talk about how these products are integrated together and how that integration is not just a hyperlink to a separate UI with a separate login with separate data. We're going to talk about how these two devices are completely integrated together seamlessly for our customers. The result, as Jim points out, is the ability to see, as he puts it, the full application delivery context, central and remote in a single console, with this unprecedented levels of detail for assessing and troubleshooting network and application performance. So we're pleased to be getting this recognition in the industry for the work that we've done over time. And before we get into the product details, I'm actually going to have Zach walk through this AA-NPM market, a bit about what that means and where we fit in that market.
Thank you, Dan. Yeah, so as Dan mentioned, I wanted to start out by just setting the stage. I know we have a mixed audience, so let's just start out by defining what is AA-NPM. We love our acronyms, right? The idea behind this is just that the network performance management market has matured over the past decades, if you will, from just monitoring networking endpoints to actually being able to, needing to start to understand the actual applications and their performance. And that's for a network engineer to actually understand that, right? Our APM guys have always, our app owners, if we will, have always focused on APM data. But what kind of data do we need as a network person to be able to troubleshoot, to manage performance, even though it's application data? And so what I've built here is a little timeline that just kind of talks about what we've come from and where we're going to in terms of monitoring. In the beginning, all we had were, I'll call legacy NPM, right? We've always been able to do things like pinging, checking uptime, getting availability. We've had device polling for decades. And of course, we've always been able to capture packets for the most part. That next level was when we started to become aware of how this stuff was being used, right? It's no longer just a utilization line on a graph. It starts to turn into data that we get from NetFlow or NBAR and actually understand, hey, I see it's 80% utilized, and now I know what that traffic is. That, of course, helps us do things like quality of service, so we can actively manage that traffic and actually start to control who's doing what and what kind of service those users will get. And then we start looking at things like response times, and that starts out with things like synthetic tests and IPSLA to start saying, well, it's not just enough to monitor these endpoints and what their interface utilization is and what traffic goes across it, but also monitor, well, how fast can I get from point A to point B? And I want to start tracking that. And then the next logical step has been, and we've seen this in the mid to late 2000s, things like TCP calculators, and finally looking at actual application transactions, but looking at them from the network layer. So as a network engineer, I need to know how fast this app is being delivered across the network. So that's just kind of that logical progression that we've gone through. And the reason we've hit that is because, it's 2014. despite what Back to the Future showed, we don't have flying cars, there are no hoverboards, right? And we still have this problem. The network is slow. We're still getting this call, right? The future hasn't arrived yet. And where do we begin to troubleshoot this? Because I bet you guys have data on all of these things. I bet you can log into these things. I bet you can pull up some tool that gives you system information on all these different endpoints. But when someone says it's slow, where do you start and how do you know you're starting in the right place? And if you find something abnormal about, hey, there's a lot of sessions on the firewall, is that related? Is that part of my problem? I don't even know. I found something anomalous and now I have to chase that down. So we're still at this point. And to answer that question of where do you begin, well, let's first convert what we've always talked about as the OSI model into reality, because where you're going to begin is probably dependent upon what's your area of responsibility. Which of these things do I own? Because that's where I'm going to begin. So if you're on the networking side, network engineers, network operations, you're going to be checking things like availability, interface utilization, link errors, connectivity issues. And so you're going to check all these things. You're going to go, it looks okay. Utilization's low. I don't see any errors. Everything looks fine. It's not the network. It's not my problem. The app guy or the server guy, he's going to look at the CPU and memory on that server. Maybe he's looking at system logs or application error logs. I don't see anything. Looks good on my end. Must be a network problem. The problem is we're just looking at these endpoints. Neither side here is taking a look at the actual delivery of what the user was trying to do. How long did it take the user to complete what they were doing? Okay? So many of these problems really require that joint ownership and expertise to say, how did it actually get delivered? How fast was it? Because at the end of the day, we're all responsible for building endpoints, whether it's servers or apps or the network nodes themselves. At the end of the day, it's all being built to deliver the application. It's trying to move data to that user. And that's what the end user's complaining about. They feel that application. They don't feel the endpoints. They're not going to call you up and say, hey, it's heavily utilized today. Oh, you're right, I have a gauge. It does say it's heavily utilized. We don't get that call, right? They say it's slow. The infrastructure's hidden from them, and that's good. We don't want them to know about the infrastructure, okay? What they care about is how quickly did it get from that end user to that server and vice versa, okay? So we need tools that monitor that, right? That was my big long lead up to the point that, hey guys, we need to monitor that. So what is TruView? Dan talked about two solutions, OptiView and TruView. I'm going to introduce TruView first, and we'll see a demo of both of these as well, so you can get in and start figuring out how does this stuff all work. You can ask me all the technical questions. But the idea, the concept is we've built a single tool to try and replace what would have traditionally been done with 5 separate tools, okay? You can see those 5 use cases here. Response time first and foremost, because when we want to troubleshoot data, again, our users call and complain about slow, that's time. We have to monitor time. So we start from that perspective and say, yes, we see that it is slower. And then we tell you where it's slower. Was it on the server side or was it on the network side? Because that's a lot of times where the majority of the troubleshooting effort goes to, is just figuring out whose problem is this to solve. It's great that as a tool you can tell me that it is slow, but I need to know where it's slow, because I need to know where to focus my teams on, where to focus my efforts and attention. So we start from that response time, and then we also are storing all the packets, so it's a stream-to-disk solution. So if you find something that you want to investigate, you can pull the packets back up for that time frame. It's also doing traffic analysis, net flow, right? So it's not just where you're capturing packets that you understand, you're also going to get that remote perspective of show me what all the WAN links are doing, show me where my end users are going, so that I can understand when I have a network performance issue, what are people doing on the network? We're also doing SNMP, device discovery and device monitoring. So we need to be able to monitor those endpoints and see what CPU, memory, interface utilization. That's still important, but we want to move away from going there first. We want to start here and see if it points us to looking at this, or see if it points us to looking at this. And then we're also monitoring voice over IP data as well. So the goal with all of this is you put this into, in many cases, a single box. We can distribute if it's a large enough environment, but the goal is this can be a single box solution. All of these 5 different data sources are in one UI. And so by putting this into a simple solution that can go from rack to reporting in less than half an hour, auto-discovers the applications, automatically configures them and starts monitoring them, and it's done in an intuitive web interface. The goal with all this, guys, is have you guys ever had to do this before? Hold on, let me check my other tool. Hold on, let me check my other tool. Hold on, let me check my other tool. Right? We have different tools for different needs. We instead build workflows based on what you're trying to troubleshoot. If you've got a network issue, there's a network troubleshooting workflow. That leads you down all the data from this pinwheel that's related to network. App issue, okay, we go down the app transaction issue, or the app workflow. So instead of trying to make you go to the network traffic data or go to the response time data, we build workflows logically. We're also going to automatically baseline performance because normal is subjective, right? What's the industry standard for network round trip time? A trick question, right? There's no normal network round trip. There's no industry standard for that. Now there is for things like VoIP, right? We have MOS scores where we can say, above this is good and below is bad. But for things like network response and application response, those are completely subjective, and it's what the user is used to experiencing day in and day out. We have to have a tool that's going to automatically tell you, guys, I've looked at this data for a month. Here's where it normally is. People are feeling this. This is way too high. And it's going to alert you to that fact. Talked about the guided workflows already. I think this kind of says it, right? This is exactly what I've been talking about. It's the idea is you have monitoring and troubleshooting. We'll tell you where the problems are and then help you get down to root cause and ideally replace you what would have been 5 tools with just one simple to use tool. Okay? I'm going to hand off to Dan, who's going to talk a little bit about the XG side.
Do you want to, before we get to that, do you want to talk a little bit about where this is deployed, a little bit about, to the extent that you can without the slide on it, about the architecture?
I've got a, probably should have just put it here. Why don't I just skip right to that appendix slide real fast?
Okay.
And, we've got a very technical audience. It does help to have a visual, like what is this magic box? Where are you putting it? What is it doing, right? So TruView, again, can be deployed in a single box solution or a distributed. Let's just say we're doing single box. You're going to put it in your data center, and it's going to receive 3 types of data. We're going to receive span or tap data. That's how we get that packet data. That's getting our response times. So it's sitting there as a stopwatch. It's also streaming those packets to disk. And that's where we're getting our voice over IP data as well. We want to span that from as close as possible to our production servers. So we're sitting off the access layer here. We're getting that data as soon as it leaves the servers, right? That way we're able to isolate how much time was spent below this line, how much time was spent above this line, network versus application. We're also going to collect the flow data that's coming from all of these remote offices or any other critical uplinks within your network, any aggregation points where you need to know what's traversing this link. And that's also going to get exported to the system. And then we'll also SNMP poll any of these servers that we're monitoring for response time that we discover, we're going to poll them. Any of these things that are sending us NetFlow data, we're going to poll them. We want to be able to give you that CPU, memory, availability, interface utilization so that we can tell, okay, we understand that it's heavily utilized and that might be related to your issue. Okay?
So on the span tap, what kind of capacity?
Oh, great question. So we have 1 gig options. So those are 2x1, 4x1, and we also have dual 10 gig options as well. And if you go back to Dan's slide earlier talking about Danaher Corporate, one of our sister companies is VSS. So that's a network packet broker. So if you ever need to go larger, we can add more boxes of our own, or we can use aggregation technologies to make sure we can fit that into an affordable pipe, if you will. Any other questions? Very good. If you want to go distributed, there's also a distributed architecture as well. Hey, maybe you've got 2 data centers. What do I have to do? Well, you put a TruView Central on top. He's going to manage all of your TruView systems. And then the TruView can just turn into a multi-collector. He can keep collecting all those different kinds of data. Again, we don't have to have separate tools for each of these. And then I can just put a multi-collector at the other side to collect that data as well. We also have options to do purely NetFlow collection, purely span collection. It will help you tailor something to meet your needs.
Do you have any additional visibility into virtual environments, right? So if you're doing service chaining through virtual appliances, things like that, those can be points of congestion, delay, and that sort of thing. I mean, are you able to look at anything deeper than just seeing the packets as they head off that virtual server and then back out.
Yeah, so we've been taking advantage of some of the span technologies that VMware has introduced, for example, in 5.1, I think it was, right? So there's vSpan. You can get that data out from the system as it's for any of that intra-host traffic, right? That stuff that would normally not ever have to hit the switch. We usually ask to, hey, just give us a little feed of that data, spit that out of the box, and we'll do that. There's also virtual tap options out there from VSS, again, one of our sister companies. So yes, we can get that data.
You said you had options for just NetFlow and so on. Does a deployment like that impact the quality of the tool, the capabilities of the tool?
So you're saying if you only did NetFlow, absolutely, yep. You're only going to be able to see where the traffic is going and what's on these links. So I can tell you, this is 80% utilized, and I can oh, sorry, not supposed to get in front. I can tell you that's 80% utilized, and that it's, the majority of it's internet traffic and where it's going to, but I can't tell you what the response time was anymore because I don't have someone calculating the response time here. I need to do that TCP acknowledgement timing to get that understanding of how fast things are.
I have a question.
Yes.
So that device right now is a hardware unit, correct?
Correct.
When is it going to be a software agent?
So we have software options as well for things like if you're doing purely NetFlow collection, that can be deployed as software only. But when we're talking about the span collection, we're actually using dedicated hardware capture cards that we ourselves have created at Fluke to do some of that analysis. So it's a unique part of the solution that you absolutely have to have an appliance to accept those in terms of that. But this guy, see how he's got the little VM logo next to him? He can be a virtual machine because he doesn't have any special hardware on him. And same thing on that NetFlow side. Nothing unique about that hardware appliance, so it can just be an off-the-shelf server if you'd like.
So your hardware can collect a full 10 gig?
Yes.
You talking about storage?
Storage, we've got a couple different options here. When you're talking about, so we've got 24 to 48 terabytes on some of our larger boxes. Working on a future release to increase that. I guess that's not secret. Anyways.
Not now.
No. Zach just said we can go larger.